All right. Now, the last topic that I'm going to look at is the effect of outliers on the regression line. We'll think about whether we could trim the data or whether we could group the data in terms of doing a linear regression. So, the objective of the lesson should be you should understand that some data set may have one or more outliers which may affect the regression line, and understand that the data can be trimmed or cropped so that a better regression line may be obtained. So in terms of trimming and cropping the data set, it will be very, very clear in the exam on the test that that's 1 point or 2 points that you have to actually get rid of. All right, it will be very, very clear. Okay. So if you look at something like this, all right, what can you observe? What is really odd with this data set? Or what about this one, and what about this? All right, think about something like this. You've got a group of data which is around here, and suddenly something that's right out there. Again, this group. You've got a group. This one, it really shows that it is a very strong linear relationship. However, what about the 4 points here? Same with this one. There could potentially be a linear relationship. What about something like this? So if you notice points like this, this, that point, and those 4 points, it may really affect the data set. So for example, what could happen? It could be something like when we are collecting rainfall information, all right? Because of the rain and the stream flow and that sort of stuff, sometimes when people collecting data, they don't actually go really close to the gauge. Stream flow gauge is like a stick with measurements in the river. So if it is really high and rapid flow, a lot of the operators will not go close and collect the data. And therefore you will have odd information like outliers. So these are the situations that where you may have outliers. All right? Now, so outliers, an outlier or outliers are points of data that differs from the overall pattern as indicated by a scatter graph. So it does not fit in that pattern. It will skew the regression line towards it, and it will add to the unreliability of any use of the regression equation. So in this case, you know that you could, if you ignore those 4 points, this could be the regression line. However, with that 4 points, the regression line could look something like this because it is skewed. It is moved towards that point. All right. So therefore, in some situation, you may really need to get rid of the outliers. So if an outlier is a consequence of an error in the collection or recording of the data set, the outlier should be removed prior to any statistical analysis. Actually, that happens. I remember a gas bill that I had was about $4,000 for 3 months. It's just because whoever read my meter actually added an extra zero. So it could happen. I've seen that happen before in real life in terms of some data that I've collected. So if an outlier is a real data point, it should not be removed unless there's evidence to suggest that the data point in question has special characteristics which are not present in the rest of the distribution. So in this case, generally when you are working, when you go out to work, when you're analyzing data, that could be the situation. However, for the exam, generally, you will notice that the data shouldn't be there. So furthermore, if there's no evidence to suggest that the outlier should be removed, a different regression may be proposed. All right, but for your exam and assessment, there should be just 1 or 2 points that you have to remove. All right. So if you look at these two situations here, exactly the same information. This one has the outlier. the outlier is here. That's included in the regression analysis. Whereas there is no outlier there, that's taken out. So you can see the difference in terms of the slope. All right, this is being pulled towards this point, therefore it is less steep compared to this one. All right, whereas this one, you can see that the correlation coefficient, one is 0.5658, which is moderate, whereas this one is high. So in this case, you can see that the outlier has a significant effect on the regression line and the correlation coefficient. So the outlier actually pulls the regression line towards itself, and you can try predicting y using both equations for 4, but I'll skip that. You can do it at home if you like to, but you can see that the number will be very different. If you draw that point, that's about 5.2. Going up there, that's about 4.5. So there you can see that there's a difference. So I'm going to skip the last bit. Now, you can trim or crop data. So trimming or cropping data set remove the outliers. You are harvesting only certain set of data for analysis. So for example, in this one, the way I would see it, I'll probably just analyze this bit. And then this bit, I can interpolate. All right? So I will not extrapolate beyond this because it's going to be unreliable. Look at it, is too scattered, whereas this is really close to one straight line. So what I would do is, I will practically get rid of all this data. I may keep these two, it really doesn't matter. These two could have been kept, but when I drew it, I decided that I'll get rid of those. I'm just concentrating on this bit. That's all. So you could crop away a whole set of data. You can see that the regression line, using this whole set, it's really different from just that bit. Okay? And if you have set of data, again, you will see that R will be a lot lower compared to that bit. So cropping that, you could think about only interpolating between 3 and 35 in this situation. Whereas this you're going to use between 3 and probably 40. And it's not going to be reliable. Think about the reliability. And then the other thing you could do is just group data. Anything that's outside this group or outside this group, I'm not going to use it. So I'm pretty sure I've seen exam question that you've got this bit, but 2 points, and you're expected to remove. And then you have to rework the coefficient, the correlation coefficient, and then you need to be able to comment on that. All right, think about how you could comment on that. One is less reliable because your correlation coefficient will be a lot lower than when the outliers are not there. All right. So in this case, I'm using only the points in the ellipse to analyze the data. Everything else is the same, remains the same, every single step, following things like inputting the data, identifying the dependent and independent, and use your class spec. All right? So that's all I have for you today. You've got exercise 70 to work on. 70 will give you 70 or 3D, I can't remember. It's in Google Classroom. Everything you will learn, you've learned today in the exercise will just show you how to trim the data, that's all. All right.